This is Gary Kayye, and we're here at ISE 2014. It's day 3 of the show, and I've had a chance to come into the private DLP suite here that Texas Instruments has. I'm with Dave Duncan. Dave Duncan was in charge of digital cinema, but now you're in charge of the 3-chip and the 1-chip group worldwide, right?
That's correct, yeah. So I've been business unit manager for what we call our 3-chip group, DLP Cinema Professional Display, since 2010, but now I manage both FP and 1-chip and 3-chip is what most people call that, yeah.
Well, the markets, I mean, first of all, you're one of the 2 technologies that basically dominate the projection market, obviously. You have DLP technology and 3-chip LCD technology that's pretty much, if you look at the everything from business room on up projectors, one of the 2 technologies is there, and they both are different in the way that they do everything. But obviously you're on the DLP side. We're going to talk about DLP.
Right.
So a couple of questions. First of all, how was 2013 for the DLP group, and economically, sort of how did you see things sort of develop in 2013? Because it was a tough year.
Actually, 2013 was a much better year than we had originally predicted. Let me talk the high end first.
Yeah.
We thought with macroeconomic conditions, and maybe even the fact that we were approaching what some people think was the end of the cinema rollout, that market would be tough. And actually, we had a much better year than what I had originally forecasted. On the FP side, last year was a pretty good year as well. It's kind of interesting that people are talking about projectors and the fact that there's so many competitors to projection in general. But you go around this show and you still see a lot of projection. And there's things that projectors can still do today that, other technologies can't.
Right. And in fact, I wrote a column recently about how I believe in 2014 is going to be the year that projectors sort of penetrate the digital signage market in a measurable way. I think it's going to be potentially as high as 5% of the digital signage market going forward. Because I think there's a lot of applications for image mapping that you can't do in spaces that you can't fulfill with flat panel display technology and size requirements.
Well, yeah, and not only mapping, but now that you see the beginning of a new category developing with laser and laser phosphor, now from a total cost of ownership and reliability standpoint, when you combine the reliability of DLP fundamental technology with now light sources that last the lifetime of the projector, it's really exciting to think about what that can bring to that industry as well. Not only signage, but really projection as a category.
Well, when are we going to see? And the big question everybody's asking is when are we going to see 4K DLP on the? Obviously it'll be a while, probably on 1-chip, but maybe you can comment on that. But on 3-chip projectors for the business applications.
Yeah. So. We were at CES earlier. Well, I guess just a couple weeks ago, and you couldn't walk the CES floor without seeing 4K. And the interesting thing now, it's curved 4K, right?
Yeah.
So we've had 4K available in the cinema and actually professional display side of our business.
Large venue display. Yeah.
That's right. Yeah. Since 2010, and it's been somewhat successful on our cinema side, but what's amazing to me is how strong the 1080p and 2K category still is for the high end, and I think a lot of it has to do with content. So on the cinema side, we're seeing movies captured in 4K. We're not seeing movies distributed. Now at CES, the big news was the new compression scheme or maybe scheme's not the right word, but the fact that I guess it's 15 megabits per second, and we start to see some streaming applications, and so that's great. So I think, like everything else, content will drive the technology change from HD to 4K. But here's the interesting thing about projection. Still in the mainstream projector space, what the highest seller is still today? Overall.
I'd say probably 800 by 600 for education.
SVGA and XGA. And it's
1024.
Yeah. And it's because you walk into classrooms and you still see, and even a lot of conference rooms, and you still see 4x3 screens.
Right. Yep.
Now, we are big promoters of wide formats. We think we make the world's best 1080p displays, both in mainstream as well as the high end. And at this show, I've actually been talking to a lot of customers about how can we go wide. So before we talk about 4K, let's at least get to 1080,
right,
and then we'll start talking about 4K. But I guess I start thinking about, conference rooms and classrooms and then get back to content. And on the projection side, is it going to be worth the burden of the additional cost when, really right now the worldwide standard is still 1080. So, but look, we understand it's here. And then, next will be 8K and who knows how many Ks in the future. So, we have roadmaps that will help our customers to provide whatever solution they're going to need for their application. And we want to get there sooner rather than later.
Yeah, I asked the question simply because, as you said, you walk around the show floor at CES and at here, there's hundreds of companies that are promoting 4K everything.
Yeah.
Whether it be even signal routing and distribution, cabling, all the way through projection and display, flat panel displays.
Yep.
So the question had to be asked.
No, I understand.
Yeah. So certainly there's currently no technology competitive to DLP that can make small projectors. I mean, you're making the smallest projectors in the world. I'm glad you mentioned that because we like to think of the DLP chip as literally the most, not only the most innovative semiconductor in the world, but the most versatile. So think about this. At CES, one of the hits of the show was a projector that big. I mean, it literally goes on a keychain. The entire projector was about the same size of the DLP chip that goes into a DLP cinema projector. So if you think about a projector that's, maybe 1 inch by 1 inch that can light up, a handheld device all the way up to DLP cinema projectors, it literally is the most versatile, in my mind, the most incredible semiconductor chip that's out there. And so we offer the ability for customers to differentiate from the small to the big, 1 chip, 3 chip, however many chips that you want. It's a really unique value proposition I think this technology provides that maybe others can't. Yeah, and what do you consider right now? I mean, the technology's evolved quite a bit. Mm-hmm. And if I were to ask you this question 10 years ago, I'm pretty sure that your answer would be very different than it is today. But what do you consider like the 2 or 3 differentiators of DLP versus 3LCD? Because you do have the people that are watching this use a lot of 3LCD, especially in the case of education and boardroom, conference room, training room. I mean, obviously, neither technology are dominant in the market. You're both sharing the market share depending on whose statistics you believe. But what do you think is if you are looking at this is your chance to tell them your sales pitch as to why you should consider DLP over 3LCD?
Well, so you're standing in a room right now that each one of these podiums, and maybe you could capture this as B-roll, each one of these podiums represents a strength or a value proposition of DLP. But I guess if I was to name, kind of a couple of my favorites, number one, reliability. I mean, look, we've had DLP cinema projectors in the field for more than 10 years, and they're still showing movies, 7 days a week, 365 days a year. So, you just can't beat the reliability, in my opinion, of a DLP chip. But then when you start thinking about accuracy of color and the ability to differentiate, I'm going to go back to this point that we offer our customers the ability to manufacture whatever kind of end product they want with regards to brightness levels for maybe a very small lamp, all the way up to greater than RGB color space, with solid state lasers and RGB lasers. Mm-hmm. And so I love the fact, and we were just having a really good conversation a minute ago when you walked in with one of our top customers about the fact that they can differentiate. They can look at the market, they can survey the market, and they say, okay, I want a product that can achieve this, and we have a solution for that space. So the fact that the ability to differentiate and the long-term reliability of our chips is just unsurpassed. So
reliability and the breadth of your product line.
Yeah, I mean, you think about it again, from Pico projectors, and we have projectors that are in mobile phones and in handheld cameras, all the way up to, it's widely known that more than 8 out of 10 movie theaters around the world, is powered by DLP cinema technology, and that's a huge statement with regard to the overall, not only color performance of DLP, but also reliability of DLP.
Mm-hmm. I think the color accuracy issue is the one that's most interesting to me because there are people that prefer the kind of color from LCD because that's what they look at on their laptop all the time, and then there's the people that prefer the color from DLP because it's what you get in a movie theater and you're sort of familiar with that color temperature.
Yeah, can I politely disagree?
Yeah, go ahead.
And here's what I want. With DLP, we have customers that make projectors that that can look very LCD-like. They can look very non-LCD-like. They can look monitor-like. They can look beyond, color spaces that are, outside the Rec. 709 color gamut. So I guess what I'm saying is, you can go look at a SKU, at a lineup of SKUs from any of our customers and see value products all the way up to, very color accurate products. And so, it gets back to what do you want to do, and then here's the technology that can enable that.
So you're contending that the color gamut is so wide with DLP that you can choose to make your projector look like LCD if you prefer that.
Well, yeah. So
In a way.
if that's what you're looking for, I mean, I'll give you an example without mentioning the customer name. Back in 2010, we had a customer that came to us and they said, we want to make a projector for a classroom that has this color space. Can you do it? One chip. Can you do it? And I said, sure. I went to one of our engineers and I said, hey, this customer wants to make a projector that has this color space, and please give them, kind of the recipe to go do that. They launched it later that year. So, again, with the tool set that we've created for our customers and the versatility of the chips that we offer, it's a matter of what do you want to build, what look are you going for. And, oh, by the way, there are projectors, with one projector that can have a mode that's maybe a home theater mode all the way to a presentation mode. So it's extremely versatile.
How many partners do you have right now that are licensing DLP technology? I don't even know. Do you know off the top of your head? Do you even know?
I probably on the one chip side, we have maybe 20. On the 3 chip side, 5 or 6. Yeah. All of DLP, gosh, there's literally thousands, because if you think about our Pico group as well as our catalog group. Our catalog group, this is a cool thing that you may or may not be aware of with DLP. So there's a part of the business that you know very well, which is the projection space, and that extends from Pico all the way up to cinema. But the great thing about this technology is now we're talking about automotive applications for heads-up displays, for interactive center consoles, and for headlight technology that is going to blow everybody away at some point. In addition, we're in stereolithography, we're in 3D printing, we're in medical applications. So, again, you talk about a technology that's versatile from IR all the way through UV and visible in between. It's kind of an unsurpassed chip technology from a not only display standpoint but also even non-display technologies. So, yeah. Lots of things to do in DLP right now.
It's an exciting the technology in general is just mind-boggling when you sit down and think about what's actually going on a chip. Years ago, I used to teach a class called The Perfect Image, and I would describe to the students exactly how DLP works and how complicated it is, but also how simple it really is. It's sort of complicated and simple at the same time. And it's always been impressive to see how that technology has come along and evolved.
Yeah, I've been working in DLP since 1995. Before that, I was in TI's Defense Systems Group. And when I first came to DLP, and the first person I met, they explained to me how this chip works. I was just amazed. And today, every time I describe it to somebody else, you just see their eyes kind of light up. They're like, "Wait a minute, are you telling me that in this chip there's 8 million mirrors, and you can control each one of them in this direction?" And now we're talking about chips that not only have bi-states, but we have tri-states.
Oh, really?
It's
the third state? On, off, and what?
Well, we have a new pixel that we've introduced that it's flat, and then it tilts this way, and then it does this. So we have effective tilt angles of much higher than what we have.
So it increased the colorimetry and grayscale calibration, or is
what it does is it increases overall efficiency. So
you're adjusting the light usage so that you're able to burn lamps at a lower temperature.
Because we have higher tilt angle, we're now 30% more efficient for a given lamp.
So you don't have to use the lamp as hard as you would, and I guess the lamp would last longer because you can crank it up over time.
Yeah, and also it's going to be optimized for. It's really, really, really optimized for solid state illumination. Étendue of those types of light sources are going to couple very, very well with this device. So. Back in the old days, we had these mirrors that just blew people's minds, and now we have new mirrors that are even more mind-boggling when you think about what they're doing. And the fact that these things last, like I said, 10 years or more is just, it's unsurpassed.
I do have one question that everybody asks me, so I'm going to ask you this question about DLP.
Hopefully I can answer it.
When will we have a 2500 ANSI lumens in that range DLP projector that's handheld. When we have a small DLP, not Pico, but more like a small
like
DLP
a laptop accessory type
exactly.
product?
It's in the 2,500 amps limits. Is that a year away, 5 years away? What's your projection on that?
Well, the first time the manager of the business unit that I'm now running told me that we'd have projectors that fit into our coat pockets, I told him he was crazy. Yeah. And it wasn't that long ago. Yeah. And now we have projectors that fit on key rings. So that's the Pico projection category. I'm not as familiar with their roadmap as I am mine, but I got to imagine it's sooner rather than later because we're already at the 1,000 lumen range. And with this new technology that we just launched, the new Pixel, with some of the new lighting that's out there today, I'm sure it's much closer than you would imagine.
Yeah, I've predicted in all the stuff I've been writing by the end of the year 2015. So I want to see how right I am. So I'm still hoping that we get close to that. So we've got a couple of years.
2 years. Yeah.
It's a lot of it depends on people like Kayye and the lighting manufacturers that you don't have a lot of control over. They've got to catch up, the LED companies. Yeah. But one little quick thing before we sign off here. We're at ISE 2014, day 3, and I appreciate you joining me. But we're running actually on our website right now. We just launched a survey, the first that I know of, independent survey of integrators, asking them based on each type of install that they do, what do they prefer, LCD and DLP, and why? Mm-hmm. So we'll be able to give you in about a month and a half the results of that survey, which is worldwide, which will give them a chance to say in a classroom, what do you prefer and why, and in a boardroom, what do you prefer and why, and in staging, what do you prefer and why. And I think it'll be a good sort of indicator out there because they can't just say that they prefer one or the other. They got to at least, give some sort of differentiator there.
Yeah.
Quantify it. So. But anyway, I think it'll be interesting to sort of see the results of that and how that goes. And both technologies obviously are popular. It's tough because I doubt you'll find too many people other than manufacturers that manufacture one or the other. And in most cases, most manufacturers, or at least a lot of manufacturers, tend to manufacture both. Mm-hmm. But most people you talk to in our industry like both technologies for different applications. And I know you'd prefer them to use DLP for everything.
Yeah,
but that's your job.
That's right.
So, but no, I think congratulations on your new role. I mean, obviously they're taking somebody who's used to the high end of the market and bringing them into the middle range of the market. So you're going to hit the ground running, and you'll help that out quite a bit because you've got that understanding of the higher end of the market. Mm-hmm. Will be able to help all of us in the middle end of the market.
Great. Thank you very much.
I appreciate you being here. This is Gary Kayye. We're at ISE 2014, Day 3. Keep watching because we got a lot more videos to shoot.